Hello, everybody. Welcome to week 4 of the Flair Educate series. We will be welcoming Anthony back for a couple of additional workshops. We kicked off with Philip last week, but we're having Anthony Madia back, and we'll be discussing FDC Deep Dive as a part 2 in continuation of the session from last week. In the meantime, make sure to say hi in chat. I'd love to see where you all coming from, and looking forward to a great session.
Thank you. Perfect. Thank you very much. So excited to be back with everybody here. I believe Philip talked a bit more. He did more of a deep dive into the attestation types. And what we're going to do today is pick that up and continue with that. And remember, FDC, just as a brief overview before we get started, it's a way that you can get information from other chains, verify that, and then use that in your applications. The Flare data connector. The more technical definition of that is you're providing cryptographic proofs for data originating outside of Flare's EVM state. Okay, so if you want to know what happened on another blockchain, you want to verify if another transaction happened, you want to verify if a payment happened, you can do that using FDC. Okay, yesterday, Philip, he talked about this attestation type, this EVM transaction attestation type, where you can verify if another transaction happened. And I believe he talked about, I talked about this before Philip came on. We ran through an example that was on the Sepolia testnet, and then verified that happened, and ran through there. And Philip went through the code of that. And I'll touch a bit more on that just to refresh everyone's memory there. And I'll go to the code here. Give me 1 second. Okay. So this is the code. This is from the Flare hard hat starter, which was shared with you a couple of times now. What Philip did is ran through this code here. Okay. This is already in the hard hat starter. When you clone it down, it's the FDC example.ts file. And it follows the flow of running through an attestation request on FDC. Okay, here's the transaction ID that you want to verify happened on the Sepolia testnet. He deployed a contract here using this function, prepared the request, and you can see the exact request body. Then he submitted the request, pulling in the FDC hub and requesting the attestation here, and then getting the proof and submitting that proof. Every attestation is going to follow a very similar flow.
Anthony, if I can just stop you for a sec. If you can zoom in a tiny bit, just so it's a bit more visible for everybody in the audience, because as of right now, when you scroll too quick, it's not. Yeah, that's perfect.
Okay, perfect.
Fantastic.
Okay, cool. So like I was saying, every attestation request is going to follow, and let me just stop the split screen a bit. Yeah. So every attestation request is going to follow this same exact flow. And for this specific attestation, we're looking at the EVM transaction verifier, verifying that another transaction happened on another chain. You want to actually pull in the transaction ID that you want first, and you can do this programmatically as well. We're hard coding this for now, and then following the flow for every attestation. So if we were to run this, you have to deploy this contract as well to have this on-chain verification. And this is the contract. You don't have to get confused with this. The most important function here is right here. Is EVM transaction proof valid? Okay. Once you get the transaction, you can verify it, pulling in the FDC verification function and then calling verify EVM transaction. This kind of function exists for the address validity attestation and the payment attestation, which we're going to go over. So that's deployed using this function. Okay, so I won't go over that. I won't run that here. Okay, then you're preparing the request. When you're submitting the request data, you're pulling in the attestation type here. It has to be hex encoded. That's why you have this 2-hex function. You see that in a lot of this code. That's all you're doing. It's nothing scary. The source type, if you use whatever chain that you're using, if you're using ETH, XRP, if this was XRP, it would be test XRP, but we're using test ETH. Putting that in the request data, and then calling this API with that request data, and then it's going to log it out. So let's run this function, and we'll see what happens here. And this is worth going over twice, because again, when I show you another attestation, the address validity very quickly after we finish this, then it's going to make a lot more sense. So we're running this on the Costin2 network, and that's the output that we're seeing. So this is all hex encoded. So if we were to take this mumbo jumbo of numbers here, which is a hex encoding, we're going to see the EVM transaction spelled out here as a string, and the test ETH all within this hex encoding. Okay, and then it submitted the request for us. Let me just see if yeah, okay. So it submitted the request and it sent it to the FDC verifiers, which if we go and open that, this is where they're verifying the transaction, because remember the infrastructure of FDC, you have all of these nodes on the network, the data verifiers, ensuring that the data is valid, it's correct, coming in from another chain, and they vote on it. In the Flare Systems Explorer, this is on the Costin network, it's going to show you exactly what happens here. And I believe Philip went over this, but it's worth reiterating. And then we didn't run the whole file, so it didn't get the attestation request. Oh, that's actually, hold on. I ran the wrong file, of course. FDC. Right, so this is the prepared request that we're getting from the prepare request function. So if we move on from the preparing request, we're going to submit the request, okay? And it's good to do this one step at a time, just to reinforce what you've already learned. You're passing in the request data into the smart contract function request attestation, which is being pulled in from the smart contract that I showed you we deployed there. And we'll show you what that looks like. And it'll bring you to that link. It'll log out right here in a second. It'll bring you to that link showing that people are, the data providers can vote on that specific attestation request, okay? It'll show you the number of the request, etc. And then you'll get the proof. And again, this is part of the flow of the FDC attestations. Let's run that function. And this is the proof that is generated that you're going to submit on chain to verify that this is valid. Okay. These are all the event logs that you're getting from that transaction ID. Remember, the whole point of this is to verify that a transaction happened on the Sepolia testnet. And now when you get that proof, we're going to go all the way to the bottom of the file here and submit that proof. And let's see what happens here. So it's taking that proof that I just showed you and submitting it. Okay. And this is the proof. This is the data that you're getting from that specific transaction that we want to verify, getting you all this information. Do you need all this information? No, you don't, because you wanted to verify, if you go back to the top of the file, that this transaction happened. And you can create some business logic, which Philip did in the last presentation, to run through all of those events that we just logged out to figure out if that transaction did happen. Now, if I'm just spitballing here, why would you want to uh, uh, do this specifically? Because some of you are thinking about projects. Well, I mean, you can think about creating a social layer, a social application saying that only certain addresses or certain users can join this application if they submitted a few transactions on the Bitcoin blockchain or something like this. It's only limited to your imagination. Okay, so let's go back to the split screen. Hopefully everyone can see this. Okay. So going back to the attestations here, I just ran through quickly what Philip talked about last week with the EVM transaction type, and it has the request body that I showed you. But now let's look at the address validity. So this asserts whether a given string represents a valid address on an external chain, on an external blockchain. For this example, we're going to be using the XRP blockchain, and it's a very simple request. Okay, you're going to uh, just take an address string that you want to verify is actually on another chain, and it'll give you a response: is it valid, uh, standard address, and standard address hash. Okay, the response isn't as important as the request, which I'll show you in a second. But if you just compare these side by side, the request and the field here to the EVM transaction that we just went over, it's a lot simpler. But additionally, the reason why I went over the EVM transaction verifier is because it follows a very similar flow. So if we go through the address validity example here, this is the XRP address that we want to verify if it's actually valid on the XRP blockchain. And we're going to first deploy the address validity checker. And again, very similar to the other flow, we're going to call in the contract registry, get the FDC verification contract, and then be calling the verify address validity function, passing in the proof to verify, have this on-chain verification to ensure nothing was tampered with, and the proof is either valid or it's not valid. Okay. Again, very similar. If we go back to the first contract I showed you, you go to the contract registry, get the FTC verification, but here you're calling the verify EVM transaction because you're using the EVM attestation. Okay, so very similar flow, and you don't have to look too much into the rest of the code here, but know that you're pulling in the FTC verification contract and calling this function specific for the address validity attestation. So you'll deploy that. I believe I deployed that already and got that address. And again, comparing it side by side, we're deploying it here. You're preparing the request. And to the left of my screen here, the attestation type is address validity. You have to hexify that. The source type, we're using the XRP blockchain. So you're using the test XRP. And then the request data. Now compare the request data side by side for a second. So you have the request data, the attestation type, and the source ID. Request body, or request data, excuse me, the attestation type, and the source ID. In the request body, I said it was a bit simpler. You're just getting the address string, passing that into the request body that you want, the XRP address that you want to verify. Okay. And this is request body is obviously different, but it shows you that the flow is the same. Now you're going to pass that into the verifier. very similar like we did here. Pass it into the verifier, and you'll get the a similar output. So let's see what happens when we run this function for the address validity example. And hopefully this works. Okay. So what it's doing is it's encoding the request using the hex encoding, and we're going to use that to submit the request. And the prepare request, I'm doing this in parts here to break it down and to present what's actually happening and being a bit more verbose about it. But if you just want to run this file, you'll go to the bottom here and you can uncomment, or you just run the verify address function, which includes all of the functionality in this file. So after preparing the request and getting that ABI encoding, you're going to submit the request. Okay, getting the request data, calling the prepare request function, and what are you doing with it? You're submitting that by calling on the FDC hub smart contract the request attestation. And when you request the attestation, you're calling the verifiers, the data verifiers, hey, come and look at my attestation and vote on it. It'll send you to the link that we showed you for the EVM transaction verifier, which if we just scroll down a bit, well, guess what? It looks a bit similar. Okay, so let's run that, see what happened here. Okay, so I ran this before and it went through, so that's why it's showing an error. But it's a very similar. You're sending the attestation to the data verifiers so they can vote on it to ensure the validity of the attestation. Okay. Then once you do that, you're going to get a proof, generate a proof for that attestation, which looks like this. You're going to get some JSON that looks very similar to this. That's what it's going to return you. And then you can finally call the verifier address function, which if we go back to what I showed you before, when we deploy the contract, it's going to pass that proof in here to have this on-chain verification. Okay. Now that's the flow. Okay. And hopefully that is starting to make sense. This is worth going over, two to three times to really understand what's happening, because it's very similar. It's very easy once you get into the flow of doing this. So we just went over the address validity, where we wanted to check if an XRP address was valid on another chain. We ran through how the request body looks like. It's very simple. It's just an address string. What the response is going to be, is this actually valid, etc. The verification process here. And this is just some information on if you're using Bitcoin, what the addresses look like on Bitcoin, etc. But what I want you to start to understand is the flow of all this happening. Okay, and if we go to the EVM transaction, and let's look at the payment. So let's say you want to use a different attestation type on FDC. You can do that using the attestation type payment. So each blockchain, it's going to specify how a payment transaction should be formatted, which we're going to use in the attestation type. So let's say, or if we compare it to the others, the request body looks like this. You have the transaction ID, which is a unique ID of the payment transaction that you want to verify happened on another chain. So if you think back to the EVM transaction, what's the first thing that we have to do? We have to get the hash of the transaction that we wanted to verify on another chain. Similarly, we're getting the transaction ID of a payment transaction that we want to verify happened on another chain. And you can read through the request here. If you're in a UTXO chain, it'll show you, explain what that is, or if you're not familiar, the rest of the request body, and then the response, which is very interesting. So it'll go through all this information, give you all this information for that specific payment ID that you want to use in your application for something. Yeah. Remember, this is only the getting you the information. I'm not really talking about what you can do with it, because what you can do with it is based on the projects that you want to build when when the series is over. And it runs through the verification process here, um, uh, and the payment summary, which I just explained to you. So when you use the attestation request, all this information is useful to use as a reference. So if we go back to the code and we look at this file here, again, it's similar that we are running through preparing an attestation request here. And let me make sure I'm on the same page here. Okay. And this is the Bitcoin transaction ID that we want. So if we're using the payment payment attestation type, we want to figure out, did a payment actually happen on another blockchain? What is that payment? You can bring that in here. This is what you want to verify. Prepare the request. So very similar like we did in the other examples. You're preparing the request. Source type, test BTC. The request data, which if you don't have to memorize this, just reference the documentation. You're passing the attestation type, the source type, and the request body, which we just went over. And again, this is what you want to verify happened in UTXO, UTXO, and then it'll give you a similar prepared request. Remember, it's encoding everything so it can then share with the other when submitting a request. Now, when you submit the request, it's getting the request data. It's getting the contracts, setting the request attestations. You're going to have to wait for the data providers to actually vote on that attestation request, and that's what you can see on the Systems Explorer. You'll have the Merkle proof here, checking the Merkle proof, getting the prepared. Oh, we went over this, and it follows a similar flow. Okay. What I want to drill down is this is what's going to be the main difference when you're using FDC. You're choosing the attestation request, passing in the right information that you want, calling the verifier, and then getting the request. And then very similar to what we saw in the EVM transaction, you're submitting that request, you're getting the proof, submitting the proof, and then that's how you use FDC. So that's what I wanted to share with everyone today. I think it was important to take this a bit slower than Philip did to review the code, but I'm happy to take questions as well from if anyone has any.
Everybody feel free to use the chat section on the bottom right side or the questions area, and I'm sure Anthony will be happy to help you all out.
Looks like no questions.
Well, looks like you've been thorough, or everybody has been quite up to date and following up on all the previous ones. Everybody, we will be having one more session. It's going to be happening this Wednesday. It's going to be the last session, and it's going to be covering a custom FDC type. So in lead up to that, if you have any questions, please make sure to voice them over on our Discord, and I'm sure we'll be able to help you out. Any last notes from your end, Anthony?
Yeah, I'm excited to go over the custom types, because some of you may need or require something custom for your own application that you build with FDC. So we'll touch on that and give a simple example of using and verifying another API to bring into FDC.
Fantastic. Everybody, thank you all for attending, and see you all on Wednesday for another interesting workshop to round up the end of the Educate series. Thank you all. Have a great day, and see you.
Thanks, guys.